So there are four electrical distributions. There's 120, 240 single phase 3-wire system. Then you have a 120, 240 3-phase 4-wire. That one is a delta high leg. And then you have a 120, 208 3-phase 4-wire system. That one's Y connected. The next one is also going to be Y connected. It's 277 480 3-phase 4-wire. All three of them are 3-phase 4-wire except for the first distribution, which is 120 240 single phase 3-wire. If you're wanting to swap the rotation on a three-phase motor, all you got to do is swap the leads. It's typically 1 and 3 or A and C, but it doesn't necessarily matter as long as you swap two of them. It'll reverse the rotation because of the magnets. For the next part, you got how to check voltage on a circuit when dealing with AC. It's going to be the V with the tilde sign. It looks like a little wave, right? The reason you would associate that one with AC is because AC comes in phases. A phase is shown as a wave, so that's a good way to remember. Next up, you have the how to check ohms, right? Ohms kind of looks like an O, but it's actually an omega symbol. If you've ever looked at Greek mythology, you'll know all about the omega symbol. It's pretty common. But when you're using your ohm meter, it has to be on a dead circuit. If it's on a live circuit, it inputs voltage into a circuit that already has voltage. Now you've overloaded the circuit and it comes back onto your meter, and that's why they come with fuses, because you'll pop it and blow the smoke out. The four steps for checking voltage on a potentially live circuit are going to be ground to neutral, and then uh, ground to phase, neutral to phase, and then finally phase to phase. You do all the benign ones first because it's safer that way to make sure that somebody didn't wire it up wrong and the ground's a hot or the neutral's a hot. You don't really know. So that's why you do ground to neutral, neutral, or my bad, ground to neutral, ground to phase, neutral to ground. I'm messing this up. Ground to neutral, ground to phase, neutral to phase, phase to phase. All right. So normally open set of contacts allow continuity. No. Open contacts are open. They're not touching. They're open. They only close when acted upon by an outside force, either some holding contacts pulling them in and holding them there, or it could be a button that only when you push it do they touch, and then as soon as you let go of the button, it lets go again. That's the opposite of a normally closed. A normally closed is going to be touching until it's acted upon by an outside force. Whether that be a holding contact that opens it up and holds it open, or it could be a button. When you press it, it opens, and then when you let go of the button, it closes again. So, the four parts of a simple circuit, you just think about fourth grade, that little light bulb system you make. It's just you need a power supply, basically like a battery or an outlet, and then you got the switch, which is just your way to turn on and off the power. Of course, it's safety. You could have it running all the time if you really wanted to. You don't want to because if something's running all the time, it wears out the components. Somebody could come up and not know that it's made like that, which it shouldn't be. So they're in the right, but they have to have a switch. Next up is the load. Of course, if you're making a circuit, if you're just running electricity through a wire, why are you doing that? It's not doing anything. You have to put a load on there. So that could be a light bulb, it could be a pump, it could be a tool, a powered tool, it could be anything. As long as it is consuming electricity and is in series with the circuit. Next up is the conductor. Conductor is just another word for wire, right? You just have to have something that connects it and gives the electricity a path to go. If you have any breaks in that, now you've lost your continuity. You have to have continuity through the circuit, which the switch is supposed to be able to open and break the continuity. Next up, we got what is the max voltage I can test with my personal multimeter. So it depends on the multimeter you have. Typically, they'll have a rating on the side. I'm not fully versed in all the ratings, but the main rating we use up at the school is going to be the Cat 3 600 volt, right? And that's, I believe it's the highest, if not one of the highest. I think there might be one tier above that. Uh, but you just have to know how many volts you're working with, and you always want it to be more than the volts you're working with. If you're working on 600 volt system and you use a 600 volt meter, that's no bueno, because you could always have a phase that goes a little bit above 600 volts, and now you're screwed. You're gonna blow the smoke out of your meter, right? So you need to say you have a 500 volt and you got a 400 volt, 500 volt, and a 600 volt meter. You need the 600 volt. You don't want to go with anything less or the same. You have to have it more. Next up, we got the three-phase motor starter contactor components. So first off, we got a coil. It's a magnet, right? Electromagnet. As soon as it is powered, it becomes a magnet, pulls things in, turns things, that type of deal. Uh, Essentially just a nail wrapped in a wire. You know, it's a magnet. Next up is the holding contacts. The holding contacts, when they're powered, pull in, right? And that could open or close a contact. So it just depends on how you have your circuit wired up. But the main thing about the holding contacts is that when there is a power, it will hold and stay that way until power is turned off, and then it lets go. Next up, we have auxiliary contacts, which they can be normally open or normally closed. Uh, it could be any other contacts that aren't, a holding contact or a main contact. Auxiliary just means extra. That's the literal definition of the word auxiliary. You can use auxiliary for more things than just contacts, but it gives you a pretty good idea of what auxiliary contacts mean. It's just contacts that are extra, that don't really do nothing unless you want them to do something. Next up, we have the contacts, which are the main contacts. They're usually located on the top side or bottom side. There's not a lot of them. There's three and three, because you have the three in and then the three out, right? The reason you typically have three, especially on a three-phase motor starter, is because three phases, right? You need a contactor for every phase. So, uh, next up is the spring. Um, it's just another part of the holding contact. Uh, Whenever it's energized, of course, uh, the spring pushes it. So that's what lets it push out or pull in is the spring. It's contracted kinetic force that, when given electricity, turns that potential force into kinetic force. Next up, you have overloads. Overloads are not present in a three-phase motor starter. Of course, if there are overloads in, like, I guess a GFCI would be a type of overload. Whenever the GFCI in a standard outlet gets too much power to it, it flips. And there's typically two little buttons on there. One will say test and one says reset. Test will, intentionally flip it. Then of course the resets your overload. All right. And I think that's about it for the questions we had to go through. So now it's just up to the review of the class. Um, let's see. We'll start with the good things. I did like how the class was laid out. It felt very intuitive and one thing after the other, so that you could learn the basics and slowly start getting into the more complicated stuff as you went on. Um, One of the things I didn't like necessarily was there were certain classes I feel just don't do very well in online class, uh, say blueprints. Uh, but electrical did fine. I liked the online section of the electrical, but the main ones I would probably change from the online only stuff would be the blueprint and the online learning. Electrical is pretty good though. One thing I would say is uh, one thing I kept encountering is that I would click on certain links and I wouldn't have permission, and then I would have to call tech support and get permission. So I'm not sure what that's all about. I don't know if it's going to be a complaint or just that we haven't quite gotten that streamlined out yet to work properly all the time. Um, But yeah, it's not that much of a gripe. It's a very fixable thing. Um, Other than that, I learned a lot. Uh, I didn't know there was a real difference between a motor and an engine before I started here. I knew you could have motors that, you know, you plugged in, uh, but it was very informative learning about the way the magnets and things worked inside of a motor. I always kind of wondered that, how it turned in there. And now that I know how it works, of course, I had a general understanding of magnets before starting the class, but knowing how the electricity passes through and the starting capacitor and everything starts off and gets it to spin and so on and so forth. It was very, I don't want to say entertaining because entertaining feels like non-informational, but I did appreciate how well done and laid out Mr. Diaz had it for us. Mr. Diaz, streamlined everything and he made sure that we knew what he was talking about before we moved on to the next thing. So, all right, thank you. That's my final.